Hey there, this is part two of our exponential function review video. So next we wanted to talk about the natural exponential function, which is f of x equals e to the x. We'll be exploring this function a lot. We'll be using it quite a lot in this class, and calculus in general is used a lot, which has the base of e, right? The number e. So e is a number like, pi, the approximation for pi is 3.14. E is a number whose approximation, usually we say e is 2.718. And e has all these digits. And so what is e? I do have a little story to tell with the number e. So when I was an undergrad, like yourselves, at my college, my professor, I was taking an upper division class, and it was number theory class, and he said this story about E, and I've always remembered it. And is, how do you know the digits of E? And so I always remember, so I want to share it with you. So E is approximately, right, 2.71828182845. And what you don't see here is 9045. And so the way that I remember the first 16 digits of E is by this little story, right? There are two things to know about President Andrew Jackson. So if you have a $20 bill, President Andrew Jackson is on the face of the $20 bill, although that's probably about to change, so I'm going to have to change my E story. So there are two things to know about President Andrew Jackson. He's the 7th President of the United States. He was elected in 1828. That's right, 1828. And in a totally unrelated matter, the angles in an isosceles right triangle are 45, 90, 45. And that gives you the first 16 digits of E. If you put in your calculator, you will say e to the 1, put 1 as an exponent, and it will give you up until, I think, the 5, maybe. So anyway, but that's the number e, and the approximation that is used is 2.718. The graph of e to the x, so this is an exponential, right? E is 2.718, so almost 3. So it's going to be looking back at these graphs from the prior video. So here's 3 to the x, so e to the x is going to be between 2 to the x and 3 to the x, right? Because e is 2.71828. So e to the x is going to fall somewhere in there in between. Here's just a general graph of e to the x. This is 0 is a horizontal asymptote, so notice we will never cross it. When you graph it on devices, it always seems like it crosses it, but it's not. Y equals 0 is a horizontal asymptote. And so this is what the graph of e to the x looks like. Right, its domain, just like with any exponential, is all real numbers, and the range for this one is 0, not including 0, to infinity, which means that y equals 0 is a horizontal asymptote. If you start doing transformations on e to the x, then you're going to change the asymptote, right? If I say graph y equals e to the x minus 1, now you are doing a vertical shift of down -1. So now your horizontal asymptote is going to be down here at y equals -1. That will be the new horizontal asymptote. Okay, so keep in mind the transformations from the prior section when working with exponentials as well. And so the domain of an exponential itself is just all real numbers, but if the exponential is part of another function, like a composition of functions, then we gotta pay attention to that domain. So let's try an example. So say I want to find a domain of this function. G of x is 5x plus 1 over that denominator that includes e to the x. Now the domain of e to the x itself is all real numbers, but now we have e to the x is just part of this denominator. So from what we know about fractions, I know that I need to exclude any value that makes the denominator 0. We cannot have the denominator be 0. So solve the equation e to the 2x plus e to the x minus 2 equals 0. And whatever makes this 0, we're going to exclude those values from the domain. So how do we do that? And this, I recognize this as a quadratic. So this kind of looks like if I had something like u squared plus u minus 2 equals 0. And the reason that I recognize that is because my middle term is e to the x, and e to the 2x, using properties of exponents, I can say this is e to the x squared, right? So I can undo the property of exponents that says power to power, you multiply the exponents. So when I see exponents multiply, that means I can do power to a power. So going backwards on that rule of exponents. And so how do we solve this equation? Ideally it factors. If it doesn't factor, then you use the quadratic formula. But this factors into, what would that be? U plus 2 and u minus 1, right? And now I can solve it. So that means that then this, I can think of it as let e to the x be u, right? So then you have e to the x squared, so e to the 2x plus e to the x minus 2. So that's exactly our expression. So that means I can factor this into e to the x plus 2 and e to the x minus 1 based on this work over here. Equals 0, and now we use the zero product property. So either e to the x plus 2 is 0 or e to the x minus 1 is 0. This one tells me e to the x is negative 2, and this one says e to the x equals 1. Well, based on the graph of e to the x, which we have up here, I know that the range is from 0 to infinity, so there are no negatives. So that means that this is not possible. Right? Negative 2 is not in the range. No negative numbers are in the range of e to the x, so this is not possible. And this one, e to the x is equal to 1 when x is 0. Right? Can you make them have the same base? E to the x equals e to the 0 will give you 1, because that's my lazy because e to the 0 is 1. You could also probably use logarithms, but we haven't gotten there yet, so I don't want to get too much into logarithms without talking about them first. But here's just a matter of how can you get 1? What exponent on e, right? X, we're looking for x. What exponent on e will give you 1? Well, anything to the 0 power is 1. So that's how I know that x is 0. All right, on our next video, we're going to talk about finding equations of exponentials given a graph. And we'll do an application also.